Welcome. This is the review of the first half of Chapter 7a. Since we did that before Christmas, after 2 weeks, I'm sure you have gotten rusty, so we are going to review it today. All right. So that wasn't what I was trying to do, but that's okay. Welcome. Today we're going to be reviewing Chapter 7a. We did this portion of the chapter before we broke for Christmas, so now we're coming back to it. So I wanted to review this because I'm sure you've gotten a bit rusty. All right, handling integer exponents. All right, notice we say integer. All right, we're back. Sorry. Okay, so, all right, notice we said integer. Integer means just a whole number, not decimal, not a fraction. Okay, so meaning x squared. This is reviewing, but it helps you lay foundation for what we're going to explain later. X squared is 2x's multiplied. X to the fourth is 4. X to the third is 3. X to the fifth is 5, right? So now we know what that means. All right, so when we multiply two terms that have the exact same base, what we're doing is, notice we have x squared, we get 2x's. X cubed, we get 3x's. So really what we have is we're going to have 5 x's all together. 1, 2, 3, 4, 5. So that is x plus to the 2 plus 3, which gives us x to the fifth. Okay, we're going to look at this one more time. X to the fourth times x squared. Well, x to the fourth generates 4x's. X squared is 2x's. Well, this is x to the 4 plus 2, which is x to the sixth. So we add the exponents. If the bases are identical and we're multiplying them, we add the exponents. Now, powers. When we raise a power to a power, x squared cubed is really x squared times x squared times x squared, right? Which is 2x's times 2x's times 2x's. This gives us 1, 2, 3 squares. So that's 3 times 2. There's 3 of them, which is x to the sixth. Okay, we're going to do this one more time. X to the fourth cubed. So this gives us 3 x to the fourth. X to the fourth, x to the fourth, x to the fourth. Well, that's 4 plus 4 plus 4, which is 3 4s. So it's x to the 3 times 4, which gives me x to the 12. Okay, hopefully that makes sense to you. I don't think I like this presenter mode, because I can't manipulate the slides. Okay, radicals and rational exponents. A radical, that's the square root sign, can be expressed as a rational exponent. So, the square root of x is x to the 1/2. The 2 here, right, there is a 2 right there, it's just not written. Like we don't write 1x, we write x. When we don't write the 2, it's just the square root. Okay, so square root of x is x over 1/2. Notice the 3 is x to the 1/3. Fourth root is x to the 1/4. Fifth root is x to the 1/5. Now we can do this with integer exponents as well as rational. So notice we have square root of x cubed. Well, that's actually x cubed to the 1/2. So we multiply the 3 and the 1/2. and then we get 3 halves. Okay, I'm erasing this so that I can have space to write out, so I'm not writing on top of stuff. Okay. Okay, so now, cube root of x squared, this is x to the 2 to the 1/3. Well, that's x to the 2 times 1/3, which is 2/3. And that gives us x to the 2/3. So in here, the 1 is implied, so it's x to the 1/4. This has an implied 1, so it becomes x to the 1/5. I had a student who described this in a cute kind of way. It might help you remember how this works. The 5 is on the bottom. He's being sat on. He's tired of being sat upon, so he jumps off and becomes the radical. So let's see if I can draw that out for you. X to the 1/3. The 3 is tired of being sat on, so he jumps off and he becomes cube root. Kind of a cute little way to remember it. All right, the next slide. Rational exponents. We need to remember a few things first. To add fractions, you need to use a common denominator, right? This is for addition only. Now, when we do that, to get that common denominator, okay, so we take the 3 that's down here and we multiply it by both sides. See, that's why we now have a 3 over 3 here. Because we're multiplying it by 1, so it doesn't change the value. We take this 4 and multiply the other one. That's why it has... Sorry, this is a typo. This should be, since that's a 4, this should be 4 over 4. Apologies, I will change it on the regular slide. Now when we multiply these, I get 3 times 5, which is 15, over 3 times 4, which is 12. And I should get 4 times 2, which is 8, over 5 times, again, 4 times 3, which is 12. All right, so now 15 plus 8 will become 23. And since it's a common denominator of 12, my final answer will have a 12 underneath. Okay, we'll have to fix that. To multiply fractions, you multiply across the numerator. So now we're doing a multiplication. Okay, so now we just simply multiply straight across. 5 times 2. 4 times 3. 5 times 2 is 10. 4 times 3 is 12. They both have 2's in them. So it would simplify to 5 over 6. To divide fractions, there are 2 different methods. I prefer the flip and multiply. I think it's easier. So you would flip and multiply. So I take the denominator, flip side power pull the